I'd like to welcome you again to today's Lucas Systems webinar, The Labor Crisis and Digital Automation. Our presenters today are Ron Cabrera. He is EVP and Chief Marketing Officer of Lucas Systems. Also presenting are Dave Cole, who's a Senior Industrial Engineer at Lucas, and Michael Nayhouse, a Modeling Engineer. So without further ado, let me turn it over to Ron Cabrera.
Super. Thanks, John. I appreciate it. And again, I appreciate you guys taking time out of your busy schedules to listen to our webinar today. I think it's a timely webinar. If you know that the season that we're in right now, there's a lot of people that are starting to get ready for their ramp up to the busy season, the busy time, which normally will create labor issues and labor booms. But the reality of what's going on in the marketplace today, I think it makes it even more dynamic. We're going to show you some data and some evidence to that as well as we go through the webinar today. And then try to share with you some ways through it. You know, how can you solve some of the issues that you're facing? And there's a lot of different options for that, but we just wanted to talk about a few of those to make it very tangible for you. So first, just starting with the labor shortage itself and what's causing it. If you can anything today, and there's a big DC boom going on right now. There's mega DCs being built, as well as there's the concept of more DCs to get closer to the consumer so you can get product to them in a much more rapid fashion. You could do this all on e-com. I think e-com has a tremendous amount of responsibility for it, but it's just the way things are today, and we have to get used to it and be able to adapt to the ever-changing order patterns in today's world. What that's doing is causing hiring and wage impacts. There's a recent article actually just out, I believe it was Friday or today, just talking about the Columbus area and how not only are they hiring a lot more workers, but it's impacting wages. And everyone working in DCs today have to deal with that and figure out how they work around that. For the labor shortage, how do you find the people that you need as well as make it a competitive environment? So what we'd like to kind of talk about is some of those labor issues. The transition from the baby boomer society to the millennial transition. It's a different mindset. It's a different culture that creates. And it's important to understand that as you evolve your organization to meet the ever-changing needs of today's world. Retention and turnover is extremely important, as well as the seasonal workers, the temporary workers that you have to hire in order to get through your peak periods. And it goes without saying, but the Amazon effect has tremendous impact on organizations today. Look at some data, some evidence out in the marketplace. You look at the number of warehouse employment numbers. This is what we start revealing to me is the last 5 years. Look at the dramatic increase in warehouse labor over the last 5 years. This is the effect that everyone's feeling out in the marketplace today. And alluded to on the previous page, those mega warehouses that are going up, that start on the right-hand side, talking about those 1 million square foot warehouses currently built up through 2016, and then those that are under contract going up. Have tremendous impact on labor, tremendous impact on wages, and how to manage through that. So we like to break things down into three main areas. First and foremost is how are you finding and hiring the skill set? It's a competitive challenge. How are you keeping your competitive, but not chasing after the rate itself? How do you make sure that when you do get those hires, you're actually retaining those? You're creating the unwanted turnover to an absolute minimum. It's always not a bad thing, but it's the unwanted turnover that has tremendous impact. And ways that you do job enrichment, ways that you create a culture for your organization, the incentive pay and how you incentivize your work staff to perform this that they can perform, and creating things like team environments are all attributed to managing the overall turnover. And then the last thing, and we're going to talk a lot about this, is how do you reduce the overall dependency for labor itself? How do you optimize the performance of your work staff so you can reduce the number of laborers that you actually need to perform the same amount of work and still driving very accurate order picks? We're going to dig into quite a bit in today's webinar. Last thing I wanted to kind of set the stage for is around automation. Automation is a big topic of discussion. No matter what event, seminar you go to, you're going to see a lot of robotics discussion, drone discussions. What we have is it takes time and it has a lot of cost in order to incorporate automation into operations. It's then scalability and how to manage it. It can scale. The time and the cost associated with it, again, is very time-consuming and costly. Finally, it's the rigidity that probably is worrisome for me. Order patterns changing constantly in the marketplace. And as order patterns change, it impacts the ability to run operations with a rigid automated process. So it's not just bringing in a new line of business. If you bring in a new line of business, unless it's a perfect fit for the order patterns and products that you're currently selling, it's going to have an impact to your overall robotics or automated processes. And then the last thing is, how do you actually build your automation? Do you build it for your peak, or build it for the 9 months of the year that's not your peak? And either way, you're going to have some issues that you're going to have to manage through during that transition. With that, what I'd like to do is turn it over to Dave Cole, who's going to start into the discussion about digital automation for us. Dave?
Thanks, Ron. Hey, everybody. So when we talk about the digital automation, we're referring to the latest digital technologies to streamline, to orchestrate the manual work processes that you're inevitably having in the DC. And second, to optimize those processes in real time using algorithms and other modeling tools. And last, the third item is the artificial intelligence to aid and improve planning and decision making that your supervisors and management team use on a daily basis. I'll talk a little bit about digitalization, but then take it a step further and talk about how applying math models and algorithms in real time to optimize your processes. Give an example of that, batch optimization to maximize the pick density that your manual work processes require to minimize the travel through DC. And then a little bit more about the relationship of how a DC can improve labor productivity, reducing training. And then I'll turn it over to Michael, and he'll do a deeper dive on the artificial intelligence. And he'll come with some concrete examples of how we use machine learning to help the challenge of the DC. Most DCs today are using a warehouse management system to direct work, using RF terminals, possibly even voice. And you can think of those as the very basic form of digitalization. We've been this in the industry for years now, using RF terminals to direct workers and to where to go, what to pick. We've been around for several years. That just takes in and automated or helps provide those workers direction. But given new challenges, to more and really more different types of orders, more efficiently than ever, as I alluded to, the labor shortage, the labor demands that the industry is putting on the industry. These are looking for solutions to optimize these manual processes. They're reducing the requirement for labor. And it goes beyond the capabilities of the standard warehouse management systems. That's where the mobile work execution comes in. Similar to a warehouse execution system, an automated system, as Ron was talking about, that many DCs use to manage their automated processes, need a mobile execution system to work in conjunction with the manual processes to improve the work processes performed manually by employees. mobile work execution software provides a more robust, flexible workflows, which will allow you to maximize efficiency in increasingly complex operations. For example, in supporting store replenishment, there are now been induced in those DCs a lot of e-commerce needs, which is a different need in the work process, the manual processes, than what a typical store replenishment DC would have. You need that flexibility. You need that ability to quickly and modify your workflows to meet both types of deliveries. The second is to use more powerful mobile applications that combine the technologies like voice or RF and also visualization. Unlike yesterday's devices, the voice-only device or the scan-only systems, the new devices that are out in the market provide you multimodal capabilities, allows you to use the best of the technologies to connect your users. That means visual, voice, scanning, and this makes it easier for them to workflows, and it also provides them some better training capabilities. With break training, the reduced training times, obviously huge when labor is of short supply, makes it easier to cross-train employees to handle different roles. And not in business for future, we're going to be using more applications on smart glasses, which will allow us to augmented reality capabilities to further improve its use in training. The mobile work execution gives managers real visibility into the performance and the work status in the DCs that you don't get in a typical warehouse management system. Therefore, the work execution systems are designed to provide the visibility into the work that's being done, not how inventory is moving. So what I mean, every talk to is focused on reducing costs and supporting this significant growth in the current DCs with a lot of labor. In the typical DC, labor is by far the largest operating cost, and half of the average DC employee's time is spent walking, traveling, riding, driving a fork truck or a pallet jack, and moving between warehouse locations. So, reducing the travel piece is an impact on the productivity of the manual labor. We're going to talk a little bit about what's that mean as we go through the rest of the presentation. So I'm going to state some things that are pretty obvious, but the real question that underlies the whole subject of smart glasses, vision picking, augmented reality, what's the best way to pick orders and to perform hands-on tasks in the DC? For the longest time, many remember and still do some areas where the pickers just had a paper pick list. They walked around, they checked off the items as they picked them. The industry moved into the mobile computers with RF devices. So place that paper with a screen-based RF device at the CAD, and you allowed them to both scanners. It actually used it to vary their location, enter their quantities, and track what they're doing in real time. Made the processes more accurate than paper. Voice recognition and voice systems were introduced. It got the worker's hands and eyes free. So we improved their work at the pick face when they were at the task at hand, but we think with their travel time. So we were improving and making them a little bit faster as they go at the pick face, but in a lot of warehouses, the travel distance and the travel time is well above 50% of the time the picker is actually picking. So the diagram illustrates that the successive studies are all focused on making the hands less very efficient and more accurate. But when you consider the total scope, you have to consider how do I reduce the travel. So over to Michael, and he's going to talk a little bit about how you do that, how a good mobile execution system does that.
All right, Dave. So traditionally, batches are created in some rule-based fashion. These rules can be based on priority, where priority is something simple as first in, first out, or some more complex such as earliest gate time by zone and or carrier. This is much more productive than picking a single order at a time, but likely to be putting those orders together in a way that is going to be sending your pickers all over the DC. What work optimization batching algorithms do is to incorporate business rules along with mathematical models of your warehouse. Apply this to an optimization problem, which is to identify batches which are the best value to the warehouse. This generally means creating batches that require travel and a higher pick density. So what do we do to determine which pick path requires travel? So what we do is we use mathematical models of the warehouse and solve a complementary optimization problem. Most take the approach of using a simple location sequence to sort the picker's pick list. Some advanced pickers may be able to optimize this based upon their own experience. However, this generally turns out to be the exception rather than the rule. What dynamic work optimization does is use multiple different path search algorithms in order to provide every picker with an optimized pick path. The volatility that exists in the warehouse might require real-time updates to the pick path. For if an aisle is blocked and the picker wishes to skip that aisle, path optimization will remove picks from the pick list and dynamically recalculate a new pick path. Last, algorithms use an individual starting location to create and determine route. This means if a picker just dropped a previous assignment at, for instance, 22 on the outside of the warehouse, then the next assignment will start from that location and finish at the appropriate dock door. This is the unique capabilities we have designed to be a part of dynamic work optimization, which not only reduces travel time during an assignment, but also between assignments for further cost savings. So to show how this works, we developed this simulation tool, which draws the pick path, generally are generated by the Lucas algorithms, and it will show the distance saved compared to a typical location sequence-based routing. So before this, I just want to mention that we know that sharing videos via WebEx isn't always reliable for all users, so please bear with us, and if the video is jumpy or doesn't stream well for you, Ron sends the presentation slides out later. He will also send you a link to this short video clip. So okay, let's play the video. So you see in the box in the bottom right-hand corner of the slide, the tool shows a comparison of the distance traveled using path optimization versus picking in location sequence. For batches, the travel savings is roughly 20 to 30%, and this is assuming pick path optimization rather than both batch and pick path optimization. If we look at the last path, for example, we see that instead of starting in aisle A and going to the right, which is what location sequence would have done, instead we're going to start in aisle G, close to where the picker starts, and then we're going to work our way over and do 2 picks in aisles E and D, followed by going to aisle A, then back to aisle F. We'll finish going through aisles G and L, so our picker back to a location which is close to the packing station. So I just went over how we can use mathematical models to improve picking productivity via batching and routing. Another way we can use these type of models is in machine learning to help improve labor planning and decision making. Learning is an application of artificial intelligence. It has the ability to learn from data without being explicitly programmed. We apply various types of learning algorithms to large sets of actual productivity data, which result in a predictive model. This helps with labor planning and can be updated continually as conditions change in the DC. In a traditional sense, labor planning was historically done using warehouse management and labor management systems. These systems relied on breaking down tasks into individual steps, recording the time to perform a step, and then calculating the time it takes for individual people to complete their work. Using this static model, they could then determine how many people they need. These activity recordings are expensive to capture and maintain. Moreover, the standard deviation can vary dramatically based on external factors like changes to the warehouse layout or reslotting of products. The holiday season, the staff dramatically increases. However, these calculations do not take into account the expertise of the staff and the impact it has on the physical DC, such as congestion. DCs don't even use these static calculations and just use Excel spreadsheets. Machine learning be used to better assist these labor planning needs. So as I said earlier, we will take historical data that is collected as a part of the warehouse activities and create predictive models to actually describe this behavior. So let's look now at an example of actual productivity data. So for this set, we have 4,834 orders, and each has different attributes. You can see as each has a work area that it's going to take place in, a user who picked it, the number of lines and units, what day did that picking start, what day of the week did it occur on, and what month of the year. And for the month of the year, it's all done in June. So we see we have the activity time in hours. So what we're going to try to predict is this activity time, final value. Data points will help us better predict this activity time. In order to determine this, we need to know more about the customer's operation. For example, they're picking nuts and bolts. Picking one line of 100 units is quite similar to picking one line of 30 units, making the number of lines more impactful. However, if we're picking large products such as refrigerators, picking one line of 10 units will likely require several trips at that same pick location, making the number of units more important. What is not machine learning is that it will look for trends in the data which help us accurately make this prediction without needing to know the specifics of the process details. The machine learning algorithm showed that for this operation, the number of lines had the highest correlation to the activity time. Next, work area, and this makes sense because a picker on a forklift versus pushing a cart is going to have a much different impact on the activity time. Third, we can hour of the day also influenced how a task was getting finished. And lastly, the actual picker who picked the product. So I hope that if we have any other data points, it will actually make our predictions worse from this set. We can then use this predictive model to help us organize work more efficiently to increase productivity. For example, if we had 5 pickers who were about to finish their work and we had 5 assignments to hand out next, who should get assignment? We can use prediction models to estimate how long it will take each of these assignments to complete and them out to pickers in a way that minimizes the total overall effort. This likely means giving your more advanced pickers the more difficult tasks, while giving easier tasks to the less experienced picker. And all this is done without taking time away from your supervisors, who would be manually organizing this work if they're doing this at all in addition to their other tasks that they must be doing. So let's a step further and look at using machine learning to help project our labor force requirements for tomorrow. You can see we have 4 inputs for this example: the estimated number of lines for tomorrow, the completion time, and the number of regular and temporary pickers we plan to have in full-time equivalents for tomorrow. Values currently in this table are going to cause us to have an estimated completion time of about 15 minutes past our desired completion time. In order to solve this, we need to add either 0.8 regular pickers or 1.3 temporary pickers. And also work the opposite way by suggesting that we may be overstaffed and that we can cut a few pickers for tomorrow. Over can help warehouses plan their workforce in a way that they are properly staffed to avoid both requiring overtime as well as to prevent idle workers long before a shift is over. So to summarize, machine learning models are dynamic within a single site, and they can adapt to different sites. They are more than static models at a lower cost to implement and maintain. And lastly, they can help eliminate over or understaffing. At this point, I will pass it back to John for some closing information as well as the Q&A.
Thanks, Michael. I just want everyone to be aware that we've also done a longer webinar focusing strictly on work optimization using, batch optimization and pick path optimization. So if anybody is interested in learning in depth those topics, you can watch one of those webinar recordings. A lot of ground today, and we do have a few questions that came in, so we'll try to get to everyone that we have. If you do have a question that you haven't submitted yet, again, please type it in the Q&A box and hit send. The first question we had come in during the presentation. So what kind of labor savings or productivity improvements could someone expect or have you seen?
I'll take it. It depends. It's very much driven by density of pick area. If you are doing voice or we from a 5 to 10% improvement if I'm not changing the travel and I'm doing case picking. My hands and eyes at the pick locations, that would be the norm for a case pick of doing a voice system only. If I could do a voice system in a dense work area, that can be in the range of 15 to 20%. Start to look at the work optimization and impacting the travel, time spent traveling. Those numbers double, triple, depending on how your starting point, obviously, to your end point. So, we've seen customers well into the 40. We got outliers at well above 50, and instead of even going 100% better. Obviously, there are outliers. I'm not telling the numbers, but that's really where it is. It's dependent on the start point and what you can impact.
Great, thank you. Okay, the second question is regarding machine learning. We're already doing labor forecasting, so why would machine learning be any better?
All right, I'll jump in on that one. So really, machine learning is about capturing trends you might not be able to see as clearly and how these multiple variables can interact with each other. So again, just so maybe you're just using, say, lines per hour or unit per hour, and you're trying to just do your estimation that way. And additionally, a supervisor is making the decision of how you should do this forecast. So what happens whenever that person changes their role or that person is no longer in that position? Then someone else is going to be doing the forecasting, maybe using an old model. Processes change. So you want to use these machine learning algorithms in a way that it can continually update its model of your processes, even when someone's not physically there and trying to update all their models all the time. So again, you give it a tool that can help assist your supervisors in the way that they do their job.
Great, thank you. One question here is, you talked about reducing turnover and improving retention. So how do these technologies impact that retention? Why don't you?
Yeah, so there's numerous ways. So it all comes down to the culture of the environment that you're working in. And what we've seen with specifically the transformation to smartphone technology, tablets within the distribution center, we have found that the culture is changing. The most specifically really embrace the technology. That's what they've grown up with. They all have smartphones. They all use the technology. No longer do they have to have a big RF gun that gets strapped to their waist. They can stick a smartphone in their pocket now, and the intuitive nature of voice makes it very rewarding for them to quickly be able to adapt to it. And they're put in that situation versus having a bigger, bulkier device. We've seen them really embrace the technology. And then you have things like incentive pay, using the concepts of things like gamification and other things that they're used to and they get excited about. We've seen a tremendous level of commitment from them and reduced turnover because of very facts.
Thanks, Ron. So it appears we're about a minute or two over our allotted time. That's all the questions we have time for today. I want to thank everyone again for attending today's webinar. Watch your email. We'll be sending around a copy of the slides as well as a link to the presentation replay. And of course, if you have any follow-up questions, feel free to email me or give us a call at 724-940-7000, and have a good afternoon. Thank you.